Hi everyone, this is Mrs. GA, and today we're going to talk about combinations and probability. All right, I have a quick warm-up for you guys, so if you could pause the video and give it a try, that would be great. All right, go ahead and take a look at their work. So to find the possible number of IDAs, it's just 10 pick 5. So you have that here. The probability that a student receives an ID with all odd numbers, so the number of permutations of all odd would be 5 pick 5, which is 120, because there's 5 odd numbers and you're using all 5. And you use the answer from part A as your total number of outcomes, and you end up with 1 over 252 when you simplify. And the probability of a student receiving the ID 1, 2, 3, 4, 5, there's only one favorable outcome. It's when it's 1, 2, 3, 4, 5. And so you do 1 over 30,240. All right, so today, instead of working with permutations, as we did in the warm-up, we're going to be working with combinations, which is a selection of objects from a group in which order is unimportant. So it is important that you keep track of which one is a permutation, which one is a combination. The way I remember it is if you think of your locker and you have a combination lock, it's actually a misnomer. It should actually be called a permutation lock because the order of your code matters. So just remember that a combination lock is not a combination. So again, the order is unimportant when we're working with combinations. So you can find the number of combinations of n objects taken r at a time with this formula. So it's n factorial over r factorial times n minus r factorial. So notice it looks very similar to our permutation formula, except we have this extra element of r factorial, and that's to take out any double counting, because again, with combinations, the order doesn't matter. So if you have A, B, C, and BAC with combinations, these would be the same thing. So we wouldn't want to double count these when we don't care about the order of the elements. So there's a few different ways you might see this n. We read it as n choose r. That's kind of the shorthand way of reading it. This is probably the most common way of writing it, but you also might see it like this. So with the C and then parentheses r comma n comma r. Or you might actually see it like this, so with the n and the r are vertical, or you might even just see it like this. So if you don't see the C next to it, and you just see parentheses with the n and the r, it is a combination. All right, let's give a few of these a try. So there are 4 boys and 8 girls on a debate team. The coach randomly selects 3 of the members to participate in the competition. So what is the probability that the coach chooses all girls? So here we would consider this a combination problem, because when you're building a team, right, it doesn't matter what order you say those people in. Like Bob, Sally, Andrew is the same team as Andrew, Sally, Bob. So for something like this, as long as they don't have specific roles that you're filling, the order of how you pick the team members does not matter. So to find the probability that the coach chooses all girls, first we need to find the total number in the sample, so the total number of combinations. So in this case, n is 12, because there's 4 plus 8, 4 boys and 3 girls, and they're selecting 3, so our r value is 3. So we can just simply do 12 choose 3, and again, this is something that your scientific calculator can do. And you end up with 220 possible combinations of teammates. But then we want to know the probability that the coach chooses all girls. So for that portion, the number of girls is 8, and they're still choosing 3. So we want to know how many different ways could the coach choose 3 girls out of the 8 girls. So let's call that event A. So here we do 8, choose 3. And again, you can do this in your calculator. And you get 56. So the probability of the coach randomly picking all girls would be 56 over 220, which we'll want to simplify, and it becomes 14 over 55. All right, now let's look at part B. This one says, what is the probability that the coach chooses all boys? So the sample, the number of combinations in our sample is going to be the same as above, but for this event, let's call it event B. For this event, there are 4 possible boys to pick from, and again, the coach is picking 3 of them. So to figure that out, we would do 4 choose 3. So here that gives us 4. So the probability that the coach will pick all boys is going to be 4 over 220, which we can simplify to 1 over 55. All right, let's try another one together. So this one says there are 52 cards in a standard deck. And remember, a standard deck has 4 suits. There's hearts and diamonds, which are red. And there's spades and clubs, which are black cards. And then in each suit, there are 13 cards. So there's the number cards, which go from 2 through 10. And then there's the face cards, Jack, Queen, King. Those are face cards. And then there's also an ace. So 5 cards are dealt from a randomly shuffled deck for a hand of poker. What is the probability that all 5 cards are diamonds? So if you're dealt a hand for poker, although you will receive 1 card first and 1 card second and 1 card third, it doesn't really matter which order those cards are in, because you could rearrange the order in your hand, right? So for when you're being dealt a hand of cards for poker, this would be a combination, because again, the order doesn't matter of the cards in your hand. So first we need to figure out how many total combinations there are in our sample set. So for this, again, there are 52 cards, and we're going to be randomly choosing 5. So this would be the total number of possibilities of hands that you could receive. And this is a very large number. It is 2,598,960 possible hands that you could be dealt. Now we want to know what the probability that all 5 cards are diamonds. So for this, to find the number of combinations in this outcome, so there are 13 diamonds, and we are choosing 5 of them. So we want to know how many different ways can you take 13 diamonds and just pick 5 of those. So the number of combinations in event A would be 13, choose 5, which is 1,287. So the probability that you would receive all 5 diamonds would be 1,287 over 2,598,960, which if you simplify it becomes 33 over 66,640. All right, I have one for you to try on your own, so please pause the video and give it a shot. All right, go ahead and check your work here. So here's the total number of combinations. So it's 26, choose 4. So again, here you're only drawing 4 cards from half the deck. And then to find the number of combinations that you can get 4 diamonds, it would be 13, choose 4. So the probability that it's all diamonds would be 715 over 14,950, which is 11 over 230. All right, so now we're going to try a couple problems that include this new key phrase that's really common with probability, and that's the word at least. So suppose a coin is flipped 3 times. Find the number of combinations where the outcome is at least 2 heads. So when you see something like this, so the outcome is at least 2 heads, really we're talking about 2 different scenarios here. We know that the outcome could be 2 heads or 3 heads. So when you see something with at least, which would be an or problem, so 2 heads or 3 heads, we're actually going to find those 2 combinations separately and then add them together. So whenever you see at least, which is something or something, we're going to add the two separate number of combinations together. So let's first talk about how we could find the total number of combinations where we get two heads. So there are 3 flips, and then we are getting 2 heads. So we're essentially asking how many different ways could we get 2 heads from 3 flips. And then the number of ways you could get 3 heads from 3 flips, well, there's 3 flips, and we want all 3 of them to be heads, so it's 3 choose 3. And 3 choose 2 is 3, 3 choose 3 is 1. So there's 4 different ways that we could get at least 2 heads. Now, for problems like this, you could also list out all of the possible outcomes that you get when you flip a coin 3 times, right? So I'm going to do that really quick. So when you do that, so these are all the different possible outcomes of your 3 flips. So when you do that, you can see that we have 4 cases where we have 2 or 3 heads, which would be at least 2 heads. So maybe you're looking at this and you're wondering, well, why is this a combination problem? Because if order doesn't matter, why are we double counting these 3 situations? So with coin flip problems, each flip of a coin is an independent event. So it might help, instead of thinking of it as the same coin flipped 3 times, let's say it's like coin A, coin B, and coin C flipped 3 times. So think of it as 3 separate coins being flipped. So it doesn't really matter which order you do it in, but think of it as flip 1, flip 2, flip 3, or think of it as 3 separate events where it's not necessarily the order that matters, but the fact that they are separate flips that matters. So that's why this is different than this and is different than this. So again, it can be kind of tricky when you're doing something 3 times in a row. It feels like the order might matter, but it really doesn't, because each flip is an independent event. Now we're going to try one similar to this, but it's going to be a probability problem. So this says a coin is flipped 5 times. What is the probability that the result is heads at least 4 of the 5 times? So for this, we need to start, since it's probability, we need to find out the total number of combinations in our sample set. And we can actually just do that by doing 2 to the power of 5, because in the first flip, again, let's think of them instead of like the same coin being flipped 3 or 5 times. Think of it as maybe 5 different coins, and I'm going to give them letters so it feels like the order isn't as important. So you have 5 different events, right? So each time you flip, so in event A or flip A, you have 2 possibilities, heads or tails, and then 2 possibilities, 2 possibilities, 2 possibilities, 2 possibilities. So since for each individual flip, you have 2 possibilities of answers, the total, or of results, the total number of combinations would be 2 to the power of 5, which is 32. Now to find the number of favorable outcomes for 4 or 5, so remember we have 5 possible flips, so 5 individual flips. And we're wondering, well, it could be 4 heads or it could be 5 heads. So this is the 4 heads, how many different combinations of 4 heads we could get, and this is how many different combinations of 5 heads we could get. So 5 choose 4 is 5, 5 choose 5 is 1. So there's 6 possible combinations of at least 4 heads. So again, when you see at least, you have to add up the individual combinations for 4 heads or 5 heads. So the probability of that happening would be 6 over 32, which is 3 over 16. All right, let's try one more together. So this says 3 dice are rolled and the result is recorded. What is the probability that at least 2 of the number cubes show a 6? So it's just a normal dice, so 1 through 6. So again, although we're rolling, since we're rolling 3 dice, it really doesn't matter what order we're rolling them in. So this would be a combination problem. But to find the total number of combinations in our sample space, we'll each roll. So we have 3 dice that we're rolling, and each time you have 6 possible options for what you could roll. So we should do 6 to the power of 3, which is 216. So that's the total number of outcomes that we could see. Now we have to find the number of favorable outcomes, which is at least 2 of the numbers showing a 6. So since it's at least 2 of the numbers showing a 6, it could be 2 of them showing a 6 or 3 of them showing a 6. So remember, when you have a case like this, we need to find those individual number of combinations and then add them together. So this one's actually a little bit trickier because of the fact that it is a dice. I'm going to break it up into 2 parts. We have to describe the number of combinations for getting 2 6s and then add it to the number of combinations for rolling 3 6s. So when you're rolling 2 6s, again, you have 3 rolls and we're getting 2 6s. So we do 3, choose 2. So this is the number of ways that you can place, like that the 6s can occur with your rolled dice. However, since it is a dice, we need to take into account what that last dice is doing, the one that's not a 6. And if it's not a 6, there are actually 5 other numbers that it could be. So we have to take these number of combinations and multiply it by 5. Because remember, this just tells you how many different ways you can get 2 6s out of 3, but this takes into account what's happening with that last dice. Now for the 3 6s, it's a little bit easier since they're all accounted for. It's just 3, choose 3. So you don't have to worry about what's happening with that third dice because they are all of them are 6s. So this we can plug into our calculator, or you can calculate it by hand. So we get 5 times 3 plus 1, 3 choose 3 is just 1. So we get 16. So that's the number of outcomes of event A. So to find the probability of event A happening, it's simply 16 over 216, which is 2 over 27. All right, so I have another one for you to try on your own. So please pause the video and hit play when you're ready to check. All right, go ahead and check your work here. So since we have a true-false test for each possible question, right, there's 6 questions that we're picking from, there's 2 possible outcomes. So it's kind of similar to flipping a coin. To find the total number of combinations, we just do 2 to the power of 6, which is 64. And then when it says at most 2 are true, that could mean that 0 of them have the answer true, 1 has the answer true, or 2 has the answer true. So remember, you're saying how many different ways or combinations can I fill those 6 slots. So 6 choose 0 plus 6 choose 1 plus 6 choose 2. We find the individual combinations and we add them up. And that gives us 22 possible combinations. So our probability is 22 over 64, which is 11 over 32. And again, if you're kind of wondering why is this a combination problem, well, it's because if if you're picking that question to be on the test, it doesn't really matter where it goes, because once it's on the test, those six problems comprise a single test. So even if you scramble the order, it's really the same test, which is again why this is a combination problem. All right, here's the last one for you to try on your own. So again, pause the video and give it a shot. All right, go ahead and check here. So here again, we have the equal number of boys and girls. So again, since there's an equal outcome for both halves, so there's half boys, half girls, and there's only 2 options, boy or girl. This is kind of like a coin flip problem. So to find the total number of combinations in your sample space, you simply do 2 to the power of 5, because each time you're picking someone, you have 2 possible options. And then to figure out the number of ways that you could have at least 3 girls, so that could mean 3 girls or 4 girls or 5 girls, you find those individual combinations and add them up, giving you 16 possible combinations. So your probability is 16 over 32, which is 1/2. Okay, that is all for the video. Thank you so much for watching.